making sense? Or it, you know, it's not something that you use every day, but you know, that there could come times when it would come in handy. So if no questions, I think I'm going to be done early today. I really don't have that much else to cover right now, unless you guys have something for me. I will go over, let's share again here.
I have a quick one about bisect, if you don't mind.
Sure.
So the example that we just did obviously was a kind of a demonstration purposes. We did the whole, you know, run the script and everything, or grep Wallace or grep text that we need to find. But like git blame does the same thing, right? It finds the commit responsible for that line, for the change. Like let's say if we are on master on the latest version, we just do let's say we find that offending piece of code, and then we do a git blame on that line that will show which commit it came from which author, right?
Yes. Yeah. So git blame, yeah, git blame shows who to blame for a particular line, but it doesn't find the line that has the problem, or you know, it doesn't find how your test failed.
So in that case, we do git bisect to rerun the scripts on each commit, kind of?
Yeah, git bisect would run an arbitrary script, and you could run it on each commit. Yeah, you could certainly go through the whole, like all the commits in the repo, but that, you know, that could be several thousand commits or more, right? And also it could be, you know, your test might take a while. So like if you've got a whole test suite, you know, maybe you could narrow your test suite down to one test. But even so, it's going to be something that you know, you can't, it's not worth running it on the whole, you know, several thousand commits. It's, you know, a binary search is just a whole lot more efficient in every scenario, just about. So, I mean, sometimes you could say, well, yeah, you know, I think I know about what it is, and poke around kind of, you know, based on an informed guess. But if it's, I don't know, you know, you maybe it's a CSS issue in a web page, right? And some CSS change somewhere did something that nobody could have predicted, but sure does show up and make the page look awful, right? And so, so that's one example of a case where you would want to use git bisect to track down what's going on. It's just sometimes it's just not obvious at all. Yeah, so good question. What I totally skipped at the beginning was forking a repo so that we could actually do the so that you guys could see the effect of, you know, of a git push where it fails. So I think that's worth talking about a little bit, if only to talk about the difference between HTTPS and SSH protocol. I'm assuming you guys haven't dealt much with kind of what that is. So if you go to, you know, a repo, I think you've seen the clone or download button here. So you have an this is actually also a button. It doesn't look like one, but it is. So you can select whether you go with SSH protocol, which looks like this format. oops, or HTTPS looks similar, but not exactly the same. You still have at the end the format of your organization, which, you know, for most people is just their user, and then the repo name .git, right? That part's the same, but the format before that is, you know, specific to that protocol. So SSH is something that's not Git. It's actually Linux. You know, it may not even Linux. It's used other places besides Linux. It's here a way to, you know, that you can see it in the way that you refer to the user and the location. So github.com is a location, and the user is Git that you come in as. And then, you know, then you've got your org repo specifier there. So why would you use one versus the other? Well, you know, here in my repo, I can look and see what I'm using by doing git remote-v. And I've got SSH protocol. So that means that I can, you know, do things like git push and things like that without typing in a password. You can do that also with HTTPS because Git will go to some trouble to cache your user login information. But that doesn't happen everywhere. So sometimes you just have to, you know, type in your login and password every time in some setups. So if you want to use SSH protocol, you can go to your settings for your account, and let's see, where is that actually? You find my glasses again. Oops. Okay. I'm going to have to put it in again. So they changed things around here. One second. This is going off of the script here for a moment. Not environment variables. Actually, let me. I'm in my repo. I need to get out of there and get into my account itself. So here we go. Okay. So if you're in your profile settings, then you'll see this. You should be able to click on that or not. Okay, well, it's not working for me. If it were, you could click on your SSH and GPG keys and add an SSH key. So, you know, if you're on Linux, there are SSH key management utilities. The basic one you would use to get a key would be something like this, and you could just, you know, hit enter through all of the prompts, and you'll get something like this in a .ssh directory. And they come in pairs. So there's the private key, which is, you know, ID RSA is a kind of key, and then there's the public version of that is the other part of the pair. There's several kinds of keys that you can create. In my case, I think I'm using the you know, the ID RSA key. And the drill is that you would, you know, take that key, public key, never your private key. Don't ever show anybody that or give it anywhere. Copy that, and then you paste it into your SSH and GPG keys. Still not so sure why I can't go and update that, but whatever. Once that's in place, then you can use the SSH authentication, because now you've told GitHub, hey, this key is authorized to access my account. So kind of just an FYI. What else did I want to cover there? So, okay, so the other thing is the forking. You'd want to fork a repo first before you clone it down, so that you would have the option to write back into it and try the git push. So if you didn't actually get a chance, which you probably didn't, to go ahead and try this I guess an anti-workflow is the thing to call it. Then go ahead and fork my repo and pull it down, and give that a whirl, because I think it will help to cement some of the concepts that we covered in the previous class. There's nothing really new here except cherry pick, and cherry pick is pretty simple. It's just take the SHA you want to plop on top of where you're at, and have it do it, have it go. But yeah, fork and clone first, and then you'll be set up to do this exercise here. Any questions on that? Doesn't matter whether you use HTTPS or Git, or I mean SSH. Either one will work for that. Okay, so that's that. At the very bottom, I think we covered this. Git show, that comes in handy fairly frequently. I think it's important to note that you can git show anything you want. Let's see, it doesn't have to be where you're at. So, like any commit, I can git show. It doesn't take me anywhere. It just shows me the diff. What happened with that commit, basically. Right? It gives me the diff of that commit versus the previous commit. So that's a great way to kind of look around and see what's going on. Doesn't change my head, doesn't change my branch, just looks at what happened with that commit and prints it out. I think the last thing I'll just take a quick look at, or just show you, is like how I did this whole presentation. I used Git itself to do it. You may have noticed that. So if I go back here to my repo, I'm on one master branch here, but there's also a GH pages branch. And this is where all the material is, and it's all in the form of Git Markdown. So if you look at the raw text, it's this Markdown format, and Git knows how. Let's see, if you put it on this GH-pages branch and check it in, Git knows how to compile it into HTML, basically. And into a static website. And so, if you have this branch and it's populated the way that it's populated here, it will compile all that down to HTML, and then you can go to that github.io. Your login.github.io, and then the repo name. And then everything on down from there is your static website. Git uses something called Jekyll to compile that Markdown and turn it into website. So if you're interested in something like that, you could play with that, and let me know, and I can give you some pointers on what I've learned. One is that you can actually run a Jekyll server locally and test it. So if I were to go to GH pages, branch. You know, here's all the stuff now. And I'm using Ruby. You can use anything that, you know, runs Jekyll, but in a Ruby environment, you know, I've got a thing that pulls in Jekyll. And Jekyll's just a server, you know, a compiler server, so I can run Jekyll here. Type it, ILL. So I first have to get the actual gems, the actual plugins installed, which is done in the Ruby way. But once I've got that up, then it just puts a little server on my local machine, and I can just look at localhost, and it publishes it on actually 4,000. Wait a minute for event machine to finish up here. Compiling. So I'd be willing to bet there's a Jekyll server for the Python world as well. Now, Jekyll uses a lot of stuff. So yeah, if you've written a README, that's the same thing that you use to write a README, is that markdown language to write README stuff. So you can't do a whole lot with it, but you know, it's surprising how much you can do. Like if you notice on the index, which is Jekyll knows, you know, to compile this, you can just reference other Jekyll pages. You know, this corresponds to a pre-work and references.md file, and so it knows to create a HTML link to that. So it's pretty straightforward to make that happen. And so you basically you write your MD, you commit push on that branch, and then after a few seconds, GitHub will go and you know, get it compiled for you, and then it will publish it for you on that other github.io site. So what's the chances this will work now? Okay, so it's compiling here, and then saying, okay, here I am on 4,000. So now if I hit enter here, so there's my site running on 4,000. And then if I change something, then it will go ahead and it'll actually recompile the file. It watches the files to see if they're if they have changed. So if I put something in here and save it off, you can see it says it's regenerating the file that's changed. So it's pretty efficient workflow for generating content and seeing that it's displaying the way you want. So yeah, that's about all I've got. I think DRW might be doing something online pretty soon. I don't know what the like how far along that's come, but you might see Renee Duquesnoy and one or two others presenting some stuff on DRW. I think we're going to do that as an alternate to what we originally planned. So I look forward to that. Any questions, comments before we wrap it up?
Chris, just thanks. You know, this was eye-opening, all of it, and also very consistent. You know, step by step, especially going down into the internals. So this was like really something new and exciting about Git.
Okay. Well, great. Yeah, thanks for staying awake. Um, it's easy to just kind of lose track, I think, in with all the details that we get into. Yeah, feel free to reach out to me on Slack anytime, and any questions or feedback on the class. Obviously, we're all trying very new things in a very concentrated way. So anything to make that go better for the next class would really be helpful. So thanks again for your attention. Have a great rest of the day, rest of the week. See you online.
Yeah, have a good rest of the week.
Thanks, Chris.
All right, you're welcome.